For decades, radar followed a familiar rule. Once it was built, it was locked. A fixed antenna, a fixed waveform, a fixed mission. Legacy radar systems were designed around hardware, metal, wiring, and physical apertures optimized for a specific threat set. If the threat changed, the radar didn't. Upgrading often meant replacing components, redesigning arrays, or building an entirely new system from scratch. That process could take years, and sometimes decades. Modern conflict exposed that limitation. Today's electromagnetic environment is crowded and contested. Stealth aircraft, drones, electronic attack, hypersonic weapons, and civilian signals all operate in the same spectrum. Threats adapt rapidly. Hardware does not. That gap forced a rethink. What if radar wasn't defined by metal and wiring, but by software? At the core of Raytheon and RTX business and its next-generation sensing is a breakthrough pioneered by its advanced technology team: software-defined apertures. This approach changes how radar works at a foundational level. Instead of being locked into a single role, the radar's aperture, the part that transmits and receives energy, is controlled by software. The same physical hardware can change how it operates, what it looks for, and how it prioritizes threats. Through software, the radar can adjust waveforms, reallocate resources, and shift missions on the fly. One moment it's scanning wide areas, the next it's refining tracks, adapting to interference, or reshaping how it sees the spectrum, without changing a single component. This radar doesn't wait for upgrades, it keeps evolving. New capabilities arrive through code, algorithms improve, performance increases over time, and this adaptability unlocks true multi-mission performance in environments designed to overwhelm static systems. But adaptability alone isn't enough. Modern combat also demands raw sensitivity, resilience against jamming, and the ability to track hundreds of air and missile threats simultaneously. That's where digital beamforming, gallium nitride transmit and receive modules, and advanced signal processing come together, allowing the radar to form multiple beams at once, look in different directions, and maintain tracks even when adversaries try to blind or deceive it. One example is Raytheon's SPY-6 radar. It takes this idea further, using modular building blocks to create a single architecture that can grow, adapt, and perform across missions and platforms. The exact same radar modular assemblies can be stacked into different configurations, from massive faces on destroyers to smaller arrays on carriers and amphibious ships, all running a common software baseline. That shared architecture simplifies training, logistics, and upgrades across the fleet. Radar is no longer a static sensor. It's a system that learns, adapts, and keeps pace with the world it's meant to see.